Here are examples of molded parts that have the defect called flash. Flash is plastic that flows beyond the mold parting lines or between metal inserts. Flash can be on the parts or on the runner. Flash can be a large area, or it can be very small, barely extending outside the cavity. Molders should avoid flashing a mold. Even if the plastic parts can be trimmed, the flash damages the parting line of the mold. The most common cause of flash is flash. If you allow flash to occur, the flash will soon depress the mold parting line. Then it will be difficult or impossible to eliminate it. Let's see how flash occurs. When the machine clamp closes, a clamping pressure develops across the surface of the mold. We can show this on a graph as a clamp pressure that's holding the mold closed. If the plastic pressure in the mold is greater than the clamp force, flash can occur. When plastic fills and packs the mold, the plastic pressure rises and the plastic pressure tries to open the mold. If the plastic pressure anywhere in the mold exceeds the clamp pressure, a gap will develop at the parting line. The viscosity of the plastic and the thickness of the gap will determine if flash does occur. For most plastics, a gap of from 0.025 to 0.05 millimeters, that's about 1/1000th to 2/1000ths of an inch, depending on the particular plastic, can be tolerated without flash occurring. The plastic will try to enter, but it immediately freezes off, blocking the flow. The problem of flash can be defined as plastic flowing outside the parting line. For flash to occur, there must be two conditions. One, a gap must either exist or develop in the mold, and two, the combination of low plastic viscosity and high plastic pressure must be enough to force the plastic to flow into the gap. We can show the problem of flash on the cause and effect diagram. The most obvious cause of flash is that the clamp force is too low. An increase in the clamp force is usually the first adjustment the molder makes. Clamp force should not be set too high. Using too high a clamp force can distort the cavities. A high clamp force can also reduce the ability of the mold to vent air. And if a small mold is put in a large machine, too high a clamp force can hob, that is, depress the platen surface. You should use only the amount of clamp force that's needed to keep the mold from flashing. The next plastic condition that can cause flash is plastic cavity pressure. Too high a plastic pressure can force parting lines to open. So another solution to a flash problem is to reduce the injection pressure. The plastic flow rate can also cause flash. After the mold is full, the inertia of the screw moving forward is converted to pressure. If this inertia is high, there is a pressure surge. If this pressure surge exceeds the clamp force in any part of the mold, the plastic can flash. To prevent this pressure surge, you would reduce the injection rate at the end of fill, or on machines with velocity to pressure transfer, you can set the VPT set point to occur earlier. Another basic plastic processing condition that can affect flash is the plastic melt temperature. The melt temperature can affect flash in two opposite ways. Lowering the melt temperature will increase the plastic viscosity, so that the plastic will not flow as easily. This will lower the cavity pressure. So the injection pressure may have to be raised to pack the mold, and this could cause flash in the runner or gate end of the part. Raising the melt temperature will decrease the plastic viscosity, so the plastic will flow more easily. The injection pressure can now be reduced because the cavities can now be filled and packed at a lower cavity pressure. So changing the melt temperature either up or down, along with changing the injection pressure, could solve a flash problem. Another plastic processing condition that affects flash is the plastic cooling rate. The cooling rate is controlled by the mold temperature. If a lower mold temperature is used, the plastic that tries to flash enters the parting line but cools more quickly. This stops the flash before it flows as far. The location of flash can be an important indicator of the cause. If the flash is occurring in the center of the mold, the packing pressure is probably causing the mold plates to deform. You should reduce the plastic viscosity so that the pressure needed to fill and pack the mold can be less. Then, reduce the packing pressure by reducing injection pressure during packing. If flash occurs on only one side of the mold or the platens may be out of parallel. Check to see if the mold closes evenly by closing the mold but not locking it tight. Check the gap around the outside using a feeler gauge or even a piece of thin paper. A wider gap on one side indicates an out of parallel condition. On a toggle clamp machine, the clamp force will change as the mold temperature is changed. An increase in the mold temperature increases the clamp force. A decrease in the mold temperature reduces it. So, with a toggle clamp molding machine, flash can occur if the mold temperature is reduced. Mold designers can help avoid flash problems by balancing the cavity layout. The cavities should be placed so that the plastic pressure is taken up equally by all the machine tie bars. The projected area that the plastic fills should not be concentrated on one side of the mold. The most common cause of flash is flash. If you allow flash to occur, the flash will soon depress the mold parting line. Then it will be difficult or impossible to eliminate it. So an important molding rule is, if you cannot eliminate a flash problem quickly, stop molding until you correct it. The type of plastic being molded affects flash. The very low viscosity plastics, such as nylon and polypropylene, can flow into very small parting lines. They flash easily. The high viscosity plastics, such as polycarbonate and polysulfone, do not flash easily. Most plastics fall in between. If filler or fiber is added to a plastic, its ability to flash is reduced.